Okay, thanks for coming. I think we can start. Welcome everyone again. It's my great pleasure to introduce you our second keynote speaker, Len Bass. Len has over 30 years of experience with software development, 25 of those at the Carnegie Mellon University at the Software Engineering Institute. He also worked for 3 years at the MITA in Australia, and is currently an adjunct member of the Carnegie Mellon University, where he teaches DevOps and also quantum computing. Len is a well-known participant now work on software architecture, evaluation and design, documentation, and also the relation to software architecture and usability. He won the NASA Administrator Awards for his work on the Mars exploration rover mission. So a little bit of history about Len. And also the Microsoft Most Valuable Professional from 2004 to 2009. Len is also an award-winning author who has lectured widely around the world. You probably know him for his books on software architecture in practice and also documenting software architecture. These books are referenced in the field. And more recently, he published another book on deployment and operations for software engineers. So today, Len will talk about the extent which DevOps he presents an evolution of earlier ideas, and we will explore also new aspects of DevOps, as well as some implications for education. These analyses are especially helpful and relevant for us because they are related to the theme of the conference this year, which is about crossing boundaries between developing and operations information systems. Before we start, an unusual reminder for attending the conference virtually. To ask questions, you must raise your hand using the native Zoom application, as you know, and we will activate your audio, so then you can speak loud and your question. At the end of the presentation, we will try to get as many questions as possible from the virtual and the in-person attendees. So please join me in welcoming Len Bass. Len, the floor is yours.
Okay, thank you. I thank the organizers for organizing this conference in very difficult circumstances. I actually wish I were there, but I'm not. So I will talk about DevOps. So the motivation for DevOps is essentially time to market. Velocity of new releases is important. So traditionally, you used to develop or deploy a new release quarterly, monthly, and internet companies do it multiple times a day. And this data is a little bit old, but there's an art supply store called Etsy that releases 90 times a day. Facebook releases twice a day, not because they couldn't do it more, but just to kind of keep things under control. Amazon has thousands of releases a day. And not from the same project. In Amazon, there are lots of different projects going on, so they have thousands. So just a definition, DevOps is a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production. And that's easy unless you're worried about quality. And so we put a clause in there about ensuring high quality. DevOps is also a movement like Agile, so you can talk about the DevOps movement if you want. but I want to cast DevOps as a process improvement effort. And there are two focuses of DevOps, of these process improvement. One is to shorten the time between a commit of software. So you've developed the software, you've committed it, and now it has to go into production. And there are a whole bunch of things that have to happen. I'll talk about those, but you want to shorten the time that that takes. And the second is to reduce the number and response time for incidents. So part of DevOps has to do with incident handling, and I'll talk about that a little bit too. So if you look at process improvement over the years, there was the CMM or the CMMI, and that was in the late 1980s. And their goal was code production. There was an effort, product line engineering. All these efforts are still going on. Nothing ever ends. I don't know if you've noticed, if you've been around long enough, but nothing ever ends in the computer business. It just keeps going. And so CMM and CMMI are still going. Product line engineering is still going. That started in the late 1990s. And the goal was to make it faster to produce new products. And DevOps dates from around the 2010s. And that's a focus on deployment and operations. So if you look at what CMMI is all about, whoops, I didn't fix the slide. It should say CMMI up at the top. It's got organizational and cultural things. So if you read about it, it's all about how you manage the organization and the culture. And I didn't do that for product line engineering either. My bad. And product line engineering added a few tools. So CMMI, the only tools they had were sort of bookkeeping tools. Product line engineering actually has a few tools to support it. But if you look at DevOps, it has both the organizational and the cultural things, which are very much like the CMMI and the product line engineering. So I'm not really going to talk too much about those aspects of it. And there's a technical side, which is fully fleshed out in DevOps, where it wasn't in the earlier efforts. And the technical side deals with tools, it deals with the processes for using those tools, and it deals with the architecture for designing the systems that you want. And so DevOps is in that sense a richer kind of process improvement effort than the other two. So if you look at process improvement for all three, and there's the notion of organization structure and the notion of metrics. So CMM and CMMI say you need a process improvement group or you can't do it. Product line engineering says there's a difference between the group that manages the product line and the group that manages the product. And DevOps has a few organizational things that I'll talk about later. You measure a process improvement, or you analyze a process improvement effort by what they measure. That's a function of what's important to them. So CMMI talks about key process indicators. That means that the only thing they're cared about are the processes. They really don't care about the product. And I used to say you could use the CMMI for canning tomatoes, which is a little bit of an exaggeration, but you know, if you're a CMMI person, you can get offended. Product line engineering measures the time to develop a new product. So at least they're getting concerned about product. DevOps has metrics for deployment and operations. So there are lots of deployment metrics. And so this is a list. It's hard to optimize any process for a lot of different metrics. And so organizations would choose these, and it's things like the deployment frequency, or how long does it take to actually deploy things? How many customer tickets do you get? What percentage of your software or your tests are passed? How many defects escape the test? How many deployments actually fail? And how long does it take to find and fix an error after deployment? Those are possible metrics. And so organizations would choose maybe 4 of those or something like that. And there are operational metrics. There's performance, there's how much traffic do you have, there's the availability, and there's utilization. Those are pretty standard kind of metrics that you monitor while the system is going. Okay, so the thing that's different about DevOps from the other process improvement is that it's really tool heavy. You really can't get into talking about DevOps unless you talk about the tools. And so the discussions are about automation and tools as opposed to the processes are sort of implicit in the use of the tools. So they fall out. You say you're going to adopt a tool and that says that was built using certain assumptions about how you're going to use it. And if you're going to use the tool, then you pretty well have to adopt those assumptions. So a big part of DevOps is just automation. And the key thing is that if you're going to do something twice or repetitively, then you ought to automate it. And so there's something called infrastructure as code. That's a buzzword. And that really means there's a script or a collection of scripts that control the action of the tools that you do. And these scripts are code, right? You have to write them, you have to test them, you have to maintain them, you have to share them. So there's overhead associated with the scripts, but it allows for repetitive actions to be invoked with a single command or a single click. So that's the virtue. So the trade-off is, how much does it cost me to maintain these scripts, to write and maintain these scripts? And what's the saving of being able to invoke them? And they're shared, they're version controlled. So you can back up. They're just, I mean, it's just like code. There's something called continuous deployment. And that means that when a developer commits code to a version control system, it gets automatically placed into production. And that's assuming that it generates no build or testing errors. And this continuous deployment is a mechanism for reducing the time to deployment. So it's just all automatic. And if you look at what the cycle is, I don't know if you can read the print underneath the labels. You start out by designing. You have to design the architecture to support the kinds of things that you want to do in terms of deployment and incident handling. And then the developers start with that architecture and they do the normal thing. They do their development. The other thing the developers do is they create the scripts. So somebody's got to write the scripts. So it's the developers or the operations people. And then you build. Okay, so there's a tool, a collection of tools that do the build, continuous integration tools. And then you go to test. You can't do continuous deployment unless you have fully automated your test. So if you're going to deploy twice a day, your testers can't test that fast. Humans aren't capable of that. And so the tests have to be automated. So there's a set of testing tools. And these are not just functional tests. These are performance tests. They're tools that generate loads. So you can see how your system operates under load. There are tools that test security. So you can see if you have any of the known vulnerabilities and so on. And finally, in that process, you sign off for a release. So the sign off could be automatic or it could be manual. There's some fields where it requires a human to actually sign off for legal reasons, financial particularly. And then you deploy it. Okay, so you actually put the thing into production. And there are tools that do that. And then you operate it. And so while it's operating, the users are doing it, and there are tools that do measurement. They gather information about the operation of the system. And that may generate incidents, which I'll come back to. But then you look at the information gathered and you analyze it. You say, where are my bottlenecks? Where are the problems? And that may affect the architecture. So you may have some feedback back to the architecture. And then you tend to want to do updates. So this is a cycle because systems are never done. You release them and then there are changes that have to be made for one reason or another. So what's the architectural support for continuous deployment? Well, there are two things. There's microservice architecture, which is now 20 years old. And there's something called version skew. So microservice architecture says I'm going to design my architecture as a collection of independently deployable processes. They're packaged as services, and they communicate only via messages. So it's strictly designed for distributed systems. And this dates from around 2002, and Amazon were the ones that came up with this. And they have a set of rules that essentially say, use microservice architectures. They didn't call it microservice architectures at the time. That name came later. But, they had a set of rules. And essentially, it said what I just said. And it allows for each service to use, the fact that you're dealing with messages, only communicating with messages allows each service to use whatever technology or languages they want. So if one service is written in Java, another service can be written in C, a third service could be written in Scala. As long as you have message handling and way to pass messages, it doesn't matter. The services are totally independent except for their messages. And Amazon also has a 2 pizza rule. Okay, no team should be larger than can be fed with 2 pizzas. So if you have very hungry team members, then that's a small number. If you have very parsimonious team members, then that could be a big, and it's around 7, which is the agile size. And each microservice is the responsibility of a single team. So if you're ready to deploy a microservice, you don't have to communicate outside the team. And it means that microservices are small and that large services are made up of many microservices. Somebody counted the number of microservices that exist in a typical Amazon front page, not the back end, just the front page, and it was 140. Places like Netflix have, and Amazon have around 1,000 different microservices. And so one problem with that is just keeping track. A request comes in, it gets passed from one service to another. And this is through the messages and the interface. And so you might think that there's a certain amount of overhead associated with the message traffic, and that's true. So you have to allow for that one way or another. And there are techniques to improve performance. But it also means that teams can deploy without coordinating with other teams. You have a service, it's ready to go. You can deploy it and go on to your next task. And so you do that by committing it to a version control system, and that triggers the deployment pipeline that I just talked about. And it goes around, and if it goes no errors, if no errors are discovered, then it goes directly into production. And that leads to something called version skew, or it goes under different names. But it's possible that you have deployed a microservice and its client with new functions, and its clients don't know about the new functions. And so they don't use it. And so they assume that you exist with an old interface. And so you have to support, your service has to support it has to be backwards compatible, has to support the old interfaces, because it's going to get requests, assuming from the old interface. The reverse can happen. Maybe a client gets updated and your service hasn't been updated yet. So you'll get requests, your service will get requests that it doesn't know what they are. Okay, and so you have to be able to handle that. And the way to deal with version skew is to tag messages with the version number of the interface. So this message is interface 3.5. I assume that the service that receives this message can handle interface 3.5, and it has to know how to do that. And so it's the responsibility of the service to manage messages reflecting different versions. I heard a talk once by Google where they talked about a particular service that was widely used, and it went through 105 upgrades of the interface. And if they got messages from version 1, it still worked. Okay, so backwards compatibility is an essence of of being able to deploy with microservices and manage version skew. Okay, so let me turn now back to the organizational aspects of DevOps. I'll start with incident handling. So what's an incident? I think you probably all know, but it's an event that could lead to the loss of or disruption of an organization's operation, service, or function. It's something bad. And there are two different types of incidents in software. One is performance or availability. So the system is slow, it's not responding, or something failed. And so you have problem with running systems. And that's what I'm going to talk about. Could also have a security breach, and that's really, I'm not going to talk about that. So what happens when you have an incident? First, you have to recognize it. So you have monitoring software, as I said, when it's being operated. And this monitoring software recognizes that there's something going wrong or about to go wrong. And so it sends out an alert. And the alert is a page. And so it sends a page to whoever is responsible for wearing the pager that day. I was surprised to learn a while ago that companies like Amazon and Netflix and Google that do this actually still use pagers. I thought everything would be text messages. But the thing about a pager is that it's guaranteed delivery. Text message is not guaranteed delivery. My son, I sent text to my son, he didn't get it till the next day. So it got there, but it was slow. So people actually use pagers. And there are a couple of different models for dealing with pages. So there's the Amazon model, which is you built it, you run it. And so what that means is that the developers for a particular microservice are the ones that carry a pager for that microservice. And if something goes wrong with that microservice, then they're the ones that are paged. And so the problem with that is that your microservice might fail because of other things that happen, not because of a problem with the microservice, but because of things that happen downstream or upstream. And so Google has something called site reliability engineers. This is a separate organizational unit. So in Amazon, the developers carry the pagers. So you already have developers, so that's no organizational changes. Google has something called site reliability engineers, and other people are adopting that too. And this is a separate organizational entity. And their responsibility is a total application. So if you look at Google, if you think about Google, they have a search function, they have a sales function, there are lots of different, they have a pay function, they have photos. Each one of those is a separate application and will have a separate collection of people, site reliability engineers. And again, that's the one that's more widely being adopted. And lots of tools. You have continuous integration tools, you have testing tools, you have monitoring tools, and so on. Okay, who manages that? Who builds them? Where do they come from? And so some organizations have a separate department whose only responsibility is tool management. And if you think about the use of tools, what happens is you introduce a new version of tool and it's changed in some either significant or insignificant way. If it's insignificant, it doesn't matter. If it's significant, then all the people that are using the tool have to have training materials. They have to be brought up to speed with what the differences are. So there's a fair amount of effort involved in managing tools. Some organizations mandate tools. They say these are the tools that we're going to use and everybody's going to use the same set of tools. So the virtue of that is that if you move people around, they know the tools. The drawback is that everybody's got to use the same set of tools. It may not be ideal for your, it's any standardization effort. It may not be ideal for your use. Somebody's got to support them. And that gets us back to having a separate department. There are organizations that allow the development teams to choose tools. So one of the lectures that I show, one of the videos that I show in my DevOps class is a lecture by George Snow, who's the head of engineering for AutoCAD, or Autodesk rather. They make AutoCAD and a whole bunch of other things. And he talks about the effort to standardize tools across their development teams. They had hundreds of different applications. And so one of the topics that I like the students to hear is the difficulty of standardizing. If you're using quality assurance, it changes the responsibilities of the QA group, and that gets into organizational and cultural issues. Right? You remember the QA team, and all of a sudden your department disappears. That can happen. Okay, what do you do? How does that affect you? And so on. And so the development teams all have unit tests for their particular components. And the QA group, one of the functions of a QA group is to have system-wide tests. And again, that's both for functional and quality. So they would worry about performance and security tests, for example, and the tools that are used to ensure that. So just to summarize, DevOps is a process improvement effort. It's concerned with deployment time and incident handling time. The metrics that you choose reflect your corporate priorities, and they reflect the emphasis in DevOps. They reflect the emphasis on deployment and incident handling. The deployment pipeline is supported by a large range of tools. And these processes have an impact on organization structure and responsibilities. So this is all summarized in a book, Deployment and Operations for Software Engineers, and that's available from Amazon. I got involved with this book. I self-published. I didn't go through a publisher. All my other books are through a publisher. And so there are pluses and minuses of self-publishing. It's relatively easy on Amazon. They give you lots of guidance, so that's a plus. The time to market is shorter. In Amazon, you finish it, you publish it. With a publisher, you finish the book, you send it to them. They go through a bunch of quality control processes. They have to set up their distribution channels. They have to print them, and it takes a long time. On the other hand, they do marketing for you, and the sales of at least the sales of my publisher published books are better than the sales of my self-published book. How's that? On the other hand, if you buy the latest version of Software Architecture and Practice, I forgot, it's around $50 US. If you buy this book from Amazon, it's around $10 US. So I think it's 10 euros in the Eurozone. So, it's a trade-off. Okay, so we have lots of time for questions. And so, have at it.
Okay, thank you. Thank you very much, Lane. I think, yes, we have a lot of time for questions. Is there any questions from the in-person audience? I'm going to quick off with a question, Lane, that came to my mind regards to human factors. Transforming towards continual deployment is challenging because it requires significant investment for a company to set up these deployment processes, as well as changing in the people's mindsets and organization. The general way of working should be changed. I was wondering if we have a sense of how far we have gotten over the last year in supporting organizations to manage these human factors when adopting DevOps. If you can discuss a little bit about this, please.
Okay, so let me just repeat the question to make sure I understood it. You're saying, have we measured the adoption rate and the supporting materials to help people adopt? Was that the question?
Yes, it's more related that how we can help organizations in the transitions when adopting DevOps to better manage the human factor. Because they have to change the way to work, and how far we have gone in these issues.
So it's an industry.
Yes.
There's an army of consultants who are more than happy to help organizations adopt DevOps practices. There are companies that will recommend a set of tools. They have a set of processes for those tools. It gets you to continuous deployment, regardless of whether you use microservice architecture or not. There are people that will help you convert to microservice architecture. There's a book by Sam Newman. I don't know if he's still at ThoughtWorks, but he used to be at ThoughtWorks, about microservice architecture. It's probably 5 or 6 years old now. So there's a raft of material and a raft of people. It's definitely an effort, so that it's like any other, it's like any other process improvement effort. You know, you don't go into it whole hog. I don't know if that phrase means anything. You go into it incrementally. So you start a pilot project. You say, okay, let's just test this in a particular environment, and see what the costs are, see what the benefits are, and measure that. And so every organization is different in that sense. And so every organization has to do their own investigation. But again, if they want help, there are hundreds of companies that are willing, or individuals that are willing to help them. I don't know. So I had a student in my DevOps class this past summer who worked at a company, and his attitude was that we don't need it. We're perfectly happy with our current processes. We pretty much have a lock on the market in our environment. And so there's no pressure for us to change our practices. So, you know, it's like anything else. You know, if you're secure in your position, if you have a monopoly of, in some sense or another, then there's no reason to change unless somebody comes along and does it better and cheaper. So I haven't seen any statistics as to what the take-up is. Every year, there are 2 reports that come out. Now, you're going to ask me what the names of those are. It's sort of like the state of DevOps in 2021. And some of them come from, one of the reports comes from Puppet. And a second report, and now I'm getting confused, I'm not absolutely sure, comes from a consortium headed by Google, although Puppet might be part of that. But if you look up if you just do a search for state of DevOps, it has, you know, they do a broad survey, and there are lots of statistics in terms of adoption.
Yes, go ahead, Alina.
Thank you for your talk. My question is, could you speak louder, please? Okay, maybe I will.
Yes.
Yeah. Can the DevOps philosophy give some guidelines, or can some best practices to help for better alignment between business and IT?
So I heard about DevOps processes and alignment. I missed the last alignment with what?
Between business and IT. Between business people and IT people, can DevOps help to
Oh,
ensure
can DevOps help with,
alignment?
no more so than anything else. The benefit of DevOps is time to market. So that's, you know, partial, that's part of the friction between the business people and the IT people. You know, if you're interested in alignment, the Agile movement is more oriented toward aligning business and the IT people. DevOps is pretty much concerned with after you've built it, what do you do?
Okay, thank you.
Okay, any other questions? Emilio?
Thank you very much, Len, for accepting to be our keynote speaker here at the ISD 2021. We are delighted with your talk. Thank you. I have a question related to measuring and knowing the levels of maturity of organizations in order to adopt the DevOps, you know.
Okay.
You talk about CMMI, for example. Is there something similar in order to know how mature are your company for adopting this kind of approaches?
Yeah, so when I was at the SEI, we used to talk about maturity models. How mature is your maturity model?
Yeah.
The CMMI people, who I don't believe are affiliated with the SEI anymore, I believe they're a separate organization, do have a DevOps maturity model. I haven't looked at it, so I don't know any details, but I do know that they were trying to integrate DevOps practices in with their normal maturity model. And again, that's part of the nothing ever dies syndrome. The way you survive as an organization is by adapting. And so, you know, the CMMI people saw DevOps as being an important thing and adapted by incorporating DevOps concepts into their model. I haven't been in touch with them for years. But if you search for CMMI DevOps, I'm sure that their name will pop up.
Yes.
No, in that line, my question is, you know that DevOps is a kind of philosophy and it's a very huge concept. So if you are intending to adopt DevOps, so is there a way to say, well, if my company wants to adopt DevOps, I should have like some requirements to say my company can reach this level of automation or that other level of automation. So in a way to say, I would start to have like a roadmap in order for adoption rather than to say yes or no, or adopt or not adopt. So to have a roadmap for adopting.
Okay, so I would start by asking the question, are you happy with your deployment frequency? How long does it take for a new piece of software to get into production? I would say that's the first question. If you're happy with your current deployment frequency, then I see no reason to go ahead and investigate DevOps deployment options. The second question I would ask is, are you happy with your incident handling process? How long does it take between the time that an incident is reported and it gets fixed? And that implies fixed and deployed back into production. If you're happy with those two numbers, then there's no reason to investigate further. If you're not happy and you want to improve one of those two numbers or both of them, then I would look at, I would first look at your deployment pipeline. What are the steps that go through? And a big time sink in the normal deployment process is the integration of different teams. So what happens is if you have a large system, you divide it into teams, and they all have to be synchronized in order to deploy. And you find a lot of integration errors. Simple things like the interfaces are wrong, more complicated things like the configuration parameters are inconsistent. And so then you have a choice. You can either try and improve the processes of coordination between the teams. Coordination takes time. So one of the things that the DevOps is totally counter to many other software engineering is that meetings are bad in a DevOps world. Meetings take time. You have to prepare them. You have to have an agenda. You have to schedule them. Everybody has to attend. You have to take notes. You have to decide, you have to verify that the notes the decisions you made are agreed on by everybody. And then you have to follow up and see that the decisions were done. Now, all that takes time. And so if you truly want to adopt DevOps, now you have to re-engineer your system to be microservices. That's a major effort. And so one of the books that I wrote, and I can't remember the title, the co-author was the co-authors were Ingo Weber and Li-Ming Zhu, has some case studies. And one of the case studies is from Atlassian, which is a tool company based in Australia. And they were refactoring their system to introduce microservices. And so in that case study, there's a discussion of how you go about that effort. And so if you want to refactor into microservices, then you want to choose services that are highly used, that are spread across your different applications. So assume you have multiple applications. Find a service in common. Break that out into a microservice, and then you have to adapt the existing systems to use the microservice, that particular microservice. So there's a philosophy of adoption into microservices. So that's on the deployment side. So the roadmap is decide whether you have a problem. If you have a problem, can you get away with just doing continuous deployment without refactoring, without re-architecting? Those are relatively cheap options. If you decide that you need to refactor, then that becomes a big effort, and you need to do that incrementally. On the other side is the incident handling. The normal incident process is that an incident's reported to the operators write up a ticket, the ticket gets sent up the chain and finally gets allocated, and the people that it's allocated to are busy. It's not their top priority, and they may have forgotten. Okay, so they have to go back and figure out what the problem is. And so that's a time-consuming process. If you're, again, happy with your incident handling process, then that's fine. If you're not happy with your incident handling process, you have to adopt some methods for speeding that up. And the one that most people are adopting is the SRE, the Google SRE. And Google has a collection of books, the SRE handbook and a couple others that were written by various people at Google describing the SRE, how to do that, and the SRE experience. But that's, again, a major effort, because now you're creating a new organizational unit. It has to learn how to work with the developers. It has to learn how to figure out the problems quickly. So the people that are in that are very sophisticated because they can do the problem solving quickly. They have a good view of an overall application. And so again, first step is to decide whether you're happy with what you have. And then if not, then what are the alternatives? And at this point, there are a fair number of source materials in terms of books and blog entries and so on to help you with that search.
Thank you, Lynn. I think we have a question over here. Yes, go ahead, Thomas.
Yes, thank you for your presentation. I wonder about the title to your keynote, Evolution or Revolution. Do you see DevOps as a, what do you say, natural evolution of agile ways of working, or do you see it as a revolution, or what are your thoughts on that?
Okay, well, one again, nothing ever dies. Let me go back to that. So one of the things that happened is that after DevOps came along, the agile people said, we've been doing that all along. And so if you look at the expansion of the agile world over the last 20 years, it's gone from essentially code production in terms of making the software meet the customer needs to being almost everything. And that's typical of any computer science or software engineering or management science sort of academic discipline. You have to keep in business. Agile in particular is driven by consultants. So they need new business. So is it a continuation of the agile philosophy? I mean, if you view the agile philosophy as saying we want to get something into production as quickly as possible, then yes, it is. If you view the agile philosophy as saying we want to produce code as quickly as possible, then it's not. So it depends which agile philosophy you want and what timestamp you're going to put on their particular manifesto. How's that for a non-answer?
Yeah, that was a good answer. Thank you.
I think there was a question from Marcela.
Thank you, Len, for your talk. I was thinking about if DevOps. Okay. Thank you very much, Len, for your talk. I was thinking about how DevOps fit for small and medium companies.
It's actually better for small and medium-sized companies because the people in small and medium-sized companies tend to be more general than those in big companies. So if you're in a big company, you're assigned you're a developer, you're assigned a particular task, and it takes you a fair amount of time to learn the context. How does this task fit into the company's organization goals and so on? If you're in a small or medium-sized company, those sorts of issues are front and center. And so you don't have specialists. So at one point in my career, I moved from the University of Rhode Island, which is a relatively small, underfunded university, to the Software Engineering Institute, which is well-funded in a major university. At the University of Rhode Island, if I had a problem, I knew who to go to. I would go to this person and I would tell them my problem, and they would say, well, when I get time, I'll be able to help you. They were overloaded. At the Software Engineering Institute, if I had a problem, the process I followed was, who knows how to deal with this problem? Once you got to that person, you were great. They would help you instantly. And so in a small or medium-sized organization, you have much more people who are much more general. They can help you with a lot more problems. They can do many more things. And that's kind of the essence of DevOps. You're moving responsibilities from operations into development. And so on. And so in a small organization where people have a broader knowledge of the various processes and a better knowledge of the corporate goals, I think it's easier to adopt DevOps.
Is there any question from the virtual attendees? Please raise your hand using the app, the Zoom app, please, if you want to ask a question to them. We do have a couple of minutes to question. Or if there are remaining questions, and if you want to write down, so please send them to the Q&A, and we will make those questions available to Lane later on. If you want to write down the question, you can also do it.
So when I teach the DevOps course, I teach it using something called inverted classrooms, which is mostly discussion. I record the lectures and then the students ask questions. I much more enjoy questions than I do lecturing.
Okay, I think there are no more questions. So thank you very much again, Len, for your talk. And thank you everyone for coming, and thank you.
My pleasure.